Hi everyone. So today we are going to talk about a very important interview question that is often asked in most of the machine learning interviews. And today we are going to talk about the bias variance trade-off. And we can start with a very simple example where like we can take a data, very simple data where we have two features x1 and x2, and we have a particular output phi. So let's say this data has nonlinear relationship with each other, and we are trying let's say we have initially we take a linear regression model and we are trying to fit a line for that data, particular data. So the basic thing that we try to do with any supervised model is that we try to reduce the error between the function that we are modeling and the function which was used to generate the data. So it is a like simpler way to understand it, and in this way we are trying to minimize the error between both of the functions. So basically moving forward, a generalizable error is divided into three parts, like bias, variance, and the irreducible part, error part. So talking about bias first, let's say like we try to fit 10 different lines from a sample of points which was drawn from the same data, and at the end we'll see that all those 10 lines will be closer to each other, will be very similar to each other. So moving forward, talking about bias. In bias, let's say taking an example, we have a complex data like which has a non-linear relationship at least, and we try to fit it with a linear regression model. Clearly we can see that the model complexity will be comparatively very lower than the complexity of the data. So here the thing is that the model is making strong assumptions about the data, and it is making assumption that the relationship between the input variable and the output variable is linear, which is clearly wrong here. And we can define bias like the inherent error caused by the assumptions made by the model for the relationships between the data. So this can be defined, bias can be defined as this, and as it is failing to capture the underlying relationships, because it is just making an assumption of the relationship, and this is called overfitting, and it is also a very important topic to be in interviews. And also talking about moving forward, we can talk about bias. If we take 10 different samples from a data from any data set, and then we try to fit a linear line, and then we compare all those linear lines, all those linear lines will be way too closer to each other, and this clearly shows that high bias clearly corresponds to low variance, because the model is making too much assumptions about the data, as it is a linear model, so it is already high bias. Then it will automatically be a low variance model, because all those points will be so much close to each other, the generalizability is so less. Yeah. So in this case, like talking about variance, here this is the low variance case, and we can also have like a case where we have a high variance. For example, if we go to the other extreme where we have a very complex model, for example we have a high polynomial degree model, x to the power 10 or x to the power 8, which has too much flexibility to turn around the data and make non-linear decision boundaries. In that we'll have the like it'll not make any assumptions, but the issue here is that it will memorize the error that is present in the data, and it will memorize the noise that is present in the data rather than being generalizable to different data sets. And if we train that model on a particular data set, then it won't perform as good as on the new data set, because it is just memorizing the errors and making a perfect decision boundary out of it. We can say like mm, uh, when the model is over like memorizing the points and memorizing the noise present in the data, then it is overfitting, and overfitting is a common problem, and we can mitigate it by certain things, like we can try regularization techniques, which is also an important topic for interviews. Other than that, So what needs to be done when we study about about the bias and about the variance? So what needs to be done? uh, we need to find a sweet spot between the variance and bias. Like we need to either it needs to be high or low, or where is the perfect sweet spot where I could get perfect model that is good at the like the predictions also, and also generalizable to new data sets. I would also like to talk about some of the additional points. Like in the equation I mentioned, there was a irreducible error term. So the irreducible error was basically the error which was itself present in the data set and cannot be mitigated through any models or anything. It is itself the error of the data set that that was there when it was created. So this is also important thing that could be asked. Also, other than that, talking about high variance models, ensemble model, like ensembling techniques are very kind of a practical solution for high variance models. And it is like trying to get the best of both worlds. And we have like ensembling methods like bagging, where we try to get multiple high variance models and average them out for making the final prediction. This gives us a better like a this gives us a like a better model which has a comparatively lower variance and having a lower bias at the same time. So concluding the things that we discussed today, bias is basically like the error caused by the assumptions that the model made and the actual relationship between the data. It is due to the difference between that. And the variance on the other hand is kind of error that is caused due to sensitivity of the model due to the training data, and not being able to generalize on new data. So, and the third one is the irreducible error, which is the error that is itself present in the data set when it was created. And these are the three things that we discussed about. And we also discussed about techniques like regularization, which are used to mitigate the overfitting of the models. And we also discussed about how ensembling helps in getting decreasing the variance of multiple weak learners and getting it like in bagging we discussed that to get the variance decreased by averaging out all the weak learners which has high variance. And other than that, you can also read multiple articles about it. I'll ping some articles in the description. And best of luck. We'll come back with another topic. Thank you.